Good evening, and once again, welcome to my YouTube channel, Pearson at Excel International Maths by Mr. Kamoto. And today I want to introduce something very important. And I want to introduce volumes of revolution around the x-axis. And earlier on, we had studied how we get the area under a certain curve within the limits AB, and if this is y is equals to the function of x, then the area between these limits is given by the integration from a to b of y with respect to x. Of course, where fx is the function, is the equation of the curve rather. And we would want to be more accurate in getting the area, and we can only do this by dividing the region into more stripes, and I would wish to just do it practically here. That is A and this is B. If we create more stripes here, then we are going to, and we take probably one stripe there. If this is x1, let's say, and this is x2, in between them there is what we call a small change in x, and that becomes the width of this shape that looks like rectangular. And of course, since y is equals to fx remains the equation of the function of the curve rather, we may want to single out this shaded region and have its height like y. So the area of this shaded stripe is length times width. You realize that the length is the height, it's actually this height which is explained so much by this equation. At this particular point, there is this value of y, so the height is y, so the area of this one stripe is given by y times the width, which is a small change in x dx. So if we want to get the area of the whole region from A to B, this region, that is that stripe, that stripe, that stripe, and also that stripe added together, you will get the total area to be equals to sigma of the area of each one of them added together. Of course, this stripe has the height y, and the width is a small change in x. The second stripe has a height y, and the width is still the small change in x, and so on and so forth. And because this sigma means sum of, it means the sum of the area of that stripe plus the area of that stripe plus the area of that stripe, all the way plus the area of that stripe, and this is what we bring together to give us the total area of the shaded region. The exact area is the limit of this sum as, of course, we know that as dx approaches 0, meaning that this dx is very small, then we are very likely to have a perfect rectangle, because we will not have this error here. The more the stripes, the more accurate we get the area. So as dx approaches 0, we have very thin stripes, and they do not welcome a big error. Therefore, as dx approaches 0, then we can talk about getting the same area almost when we integrate between a to b y with respect to x. The reason why we say this is because we know the moment we integrate the function with respect to x, of course with these limits, we get the exact area of this shaded region. So as dx approaches 0, we approach getting the very exact area as well. And we are told that you can use a similar technique to find the volume of an object created by rotating a curve around a coordinate x-axis. And if each of these stripes is rotated through 2 pi radians, if each of these stripe is rotated through 2 pi radians, or rather 360 degrees about the x-axis, it will form a shape that is approximately cylindrical. And I want us to just try doing that. And if you talk about this particular stripe, let us talk about this stripe, this single stripe, rotating it through the x-axis. We rotate it through the x-axis this way. We are going to have something that may appear to look like this. That is the x-axis, and that is the curve, and this stripe is going to be that way, and the same stripe. Now when we rotate it along the x-axis, we consider to have that particular stripe now produced below the x-axis, and the moment we have it that way, that is what we are likely to get. Remember, this height was y, and because we are rotating around the x-axis, the same y will be seen to be like that. And therefore, if we have the whole now volume kind of solid here, it is going to be a solid or a space that has volume. If you would want now to just explain this, what we have done, remember that height is still dx and the radius is y. If we may want to have this cylinder drawn differently, we are going to have it look like this. We're going to have it look like this, and this is the x-axis, so this part, that is y, and this part is now the dx. This is y, which comes here, and this is the height. So you can see, in a nutshell, radius is y, and the height of a cylinder is simply dx. So we can get the volume of this cylinder. It goes without saying, the volume of a cylinder is of course given by volume, given by pi r squared times the height. So the volume in this particular case is pi, r squared is y squared, times the height, which is dx. And if we want now to get, if all these stripes, assuming they are many, if all these stripes, they are rotated through the same x-axis, all around the same x-axis, each one of them will create a volume, and the wind will still be the delta x, and the radius will continue to be y. So we have to get the volume of that one, plus the volume of that one, plus the volume of that stripe, and plus the volume of that stripe. And therefore, when they are many, we get the volume to be equals to sigma. We are adding the volumes together. Sigma of pi y squared dx. And of course, the exact volume is the limit. As dx approaches 0, we need to realize that the volume you're going to get is almost equivalent to when we integrate pi y squared with respect to x, because this is the most accurate of getting the volume. Now, the volume of the revolution formed when y is equals to the function of x, and let me just put it over here. The volume of the solid will be the volume of the solid after revolution, of the revolution formed when y is equals to the function of x is rotated through 2 pi radians about the x-axis, between, of course, we have to have limit between x is equals to a and x is equals to b, is given by now this, what we have acquired, just this volume is given by volume is equals to pi. You integrate from a to b, y squared dx, and we have been able to outline this formula from the beginning. And we are saying that if this is the a limit and this is the b limit, the summation of all this volume when rotated will be given by this formula. Please note, it's generated from the volume of pi r squared h, and now that we have understood the r is y and h is delta x, so from this particular point to this point, when rotated together, each of these stripe will form some volume, and all of them put together will be given by the pi integral from a to b of y squared dx. And that is just on the to actually use formula in the next example. Once again, go to my YouTube channel, subscribe and share widely, and of course, be on the lookout. And thank you so much. Let's move together.